This is the Math 1111 Zoom meeting for 9 o'clock, Monday, 9/28. We have a participant tonight. Did you have any questions you wanted to ask?
No, I didn't have any major questions.
Okay. Did you want me to go ahead and go over the assignments for this week and then give an introduction to section 2.8? That's what we're covering.
Yes, please.
Okay. I pretty much can, give it from the same notes that I did. You probably didn't get a chance to watch the 12 o'clock Zoom meeting then.
No, I was at work.
Okay, no problem. Okay, yeah, the assignments for this week are Math 1111, week of 9/28 to Friday 10/2, section 2.8. And we will have no quiz this week because we're finishing chapter 2. So we will have test 2 proctored. Covers 2.1, 2.2, 2.3, 2.4, 2.6, 2.7, and 2.8. We'll have it available on Friday 10/2 and due Sunday 10/4. It'll have the same format as your first test and as the quiz. It's just that it will be done and proctored inside D2L, and I'm going to hand out instructions for that. So I will also give out a practice test with a key. Further instructions will be given this week. So the practice problems for this week are page 262, problems 7 to 23 odd, 37 and 39, and 49 to 69 odd. And on WebAssign, we're doing the personal study plan, section 2.8 practice quiz, just have 4 problems, 1, 3, 5, and 6 only. And you can just email me the percent of these 4 problems that you get correct. So you want me to just go ahead and charge into 2.8?
Yes, please.
Okay. 2.8 was about finding one-to-one functions and their inverses. I can come down, there we are. And basically it asks the question how to undo functions. And you probably are used to square root and x squared.
Yes, sir.
So you would know that square root of x squared is equal to x. That these things undo each other. And then I can do the keys in reverse order, a square root of x and I square it. You would know that these cancel each other and I wind up with what's underneath, which is x. And so what happens is, these are paired on your calculator, just to make that point. If you look at your squared key, right above it is square root. Functions that undo each other are paired on the calculator. In chapter, that's how your calculator is organized. We're going to hit ln and e to the x. That's chapter 4, same and as well as log and 10 to the x. That's chapter 4. Trigonometry. I don't know if you took any trig in high school, but you deal with these keys: sine, cosine, and tangent. Right above it, you have the sine -1, cosine -1, tangent -1. They undo these keys. You'll see that in trigonometry.
Okay.
All right, so I kind of teach this section backwards because there's a test for whether a function has an inverse. And to me, to understand what the test is, you have to understand how you undo a function, which basically finds an inverse. There's 3 steps to it. If you took high school algebra 2, you may have seen this. I just picked an example, 2x plus 1. So to undo it, you follow 3 steps. Step 1, you put in a y where this f of x is. It's easier to work with y rather than that straight f of x. So we're going to call it y equals 2x plus 1. So then step 2 is the key. You switch the x and y. So wherever there's a y, you put an x, and wherever there's an x, you stick a y. And so that makes it look like this.
Mhm.
Does this ring a bell? You seen this
Yes,
before?
sir.
So in step 3, you are solving for the y. And you do whatever algebra you have to do that. On this one, you'd subtract 1 from both sides, giving you x minus 1 equals a 2y. Then you divide by 2 to get rid of that 2, divide both sides by 2, and you wind up with this formula. We're going to call that the inverse function, and they use this f minus 1 notation. It's read f inverse of x. You can kind of argue it this way. Notice in the original, you're multiplying by 2 and adding 1.
Mhm.
So in the inverse, you're kind of doing those inverse operations. Instead of adding 1, you're subtracting 1. That's inverse to add. Kind of doing the opposite of what it's shown here. Multiplying by 2, so in the inverse, you divide by 2. That's what'll undo things. Okay, to kind of show that this really does work, that f inverse undoes, bring it down, f inverse undoes f of x. To show this, you've got to show, here's the gibberish. This basically means you plug f into f inverse and watch everything cancel, giving out what's in the middle here, x. But it also must be done in the other order, f of f inverse of that. You got to be able to plug f inverse into the f, watch things cancel and get out the x, the input here. In plain English, you plug one into the other, watch everything cancel. You got to be able to plug the original f into the f inverse and the original f inverse, or the f inverse you found, into the f in both directions. I'll just go ahead and use this example because I'll have you do this in the homework. So for this one, for f inverse, again, here's the f. On the screen here. Here's the f inverse. So this is why we did all that plugging functions into each other last section. For this one, an f inverse of f of x, I put the f of x in here, the 2x plus 1, and then I plug 2x plus 1 where there's an x in the f inverse. So that'll give me the 2x plus 1 for this x. Then you minus 1 and divide the whole thing by 2. So can you tell the top? We'll go to the 1 minus 1 is 0. You'll have 2x divided by 2. The 2's will cancel. You'll be left with x. So that just means literally that the f inverse of f of x just undoes itself and you wind up with that x, whatever's in the middle. Questions about that?
No.
So in reverse order, so to be true inverses, it's got to work in the reverse order. So that means f of f inverse of x. So I put in the f inverse for this in here, plug this formula into the f, and the f says double the x and add 1. So I'm going to double this and then add 1. 2's cancel, that undoes. You're left with the x minus 1, add 1. Minus 1, 1 cancels, leaves me the x. So this shows that the f and f inverse are inverse. They cancel each other out, just basically going in a big circle. Questions about that?
No, sir.
So the section starts with a test for inverse. And it's a horizontal line test. So to understand, why is it horizontal? To understand why it's actually horizontal, you got to go back, remind yourself about vertical line test for function. So if you remember your vertical line test, I'll use x squared. Your input is your X, your output is your Y, and a vertical line, there's only one output for any single input. So a vertical line must intersect only once anywhere to be a function. Vertical line test.
Mhm.
Okay, well, if we then go on to have an inverse, the key is that step 2, switch the X and Y. The function has to be what's called one-to-one, and the key is step 2. When you switch your X and Y, you switch your input and your output. So to find your inverse, I'm showing the same X squared curve, but with step 2, your input is now on your Y and your output is X.
Right.
And it's the same idea. You can only, for any single input, you can only have one place to go. But you can see for straight X squared here, there's 2 places to go. X squared fails. It has no inverse. This is not one-to-one. That's the book gibberish for this. Well, that's really funny because I could have swore previous pages we pointed out that X squared has an inverse of square root. Oh no! So yeah, your vertical line test becomes a horizontal line test. It's the same idea. You can only intersect once, but it's a horizontal line test for inverse, and X squared is not one-to-one and has no inverse. The secret to this is that this is not the version of X squared your calculator is using. We'll call this version, it's like software, version 1, version 2. Version 1, just again, the pure X squared here, your domain's running from minus infinity to infinity. So this fails the horizontal line test. It has no inverse. So this is not the version the calculator is using. This is called restricting the domain. We're going to use, I call it version 2. These are just my names. Version, your calculator uses what I'll call version 2. If you kind of see where you can split the curve, you can't let it curl up on itself. So you kind of split it here in the middle, right here. And if you do that, that's called restricting the domain. We're going to use it from 0 forward. So basically domain from 0 to infinity. And now you see your inputs up here, your outputs out here, and there's only one place to go. This passes your horizontal line test and has an inverse. I ran through the same thing. To find your inverse, I just went ahead and ran through the 3 steps. Put in y is x squared. Maybe before we do that, should we pause for questions? I might be going.
No, I understand right now.
Okay. So yeah, step 1, y is x squared. Step 2, switch the x and y. Step 3, solve for y, which just means I need a square root on both sides. Square root of y squared is y. I switched it, so y is the square root of x, and that's your f inverse. I went ahead and plugged in both conditions, f inverse of f. That would be f inverse of the x squared. Your f up here is x squared. That says take your square root of x squared, and sure enough, you get out x. If you do it in reverse order, put the f inverse is the square root of x inside. Plug that into f, that's the square root of x squared, and sure enough, you get out x. Questions about that?
No, sir.
So, only one other property they show you is called the graph of an inverse function. If you take a graph, I'll use the first 2 I did, 2x plus 1 and x minus 1. I'll go ahead and draw the graph again. Two x plus 1, that's the original f. I'll put in x inverse, f inverse, you'll need parentheses around that. Parentheses minus 1 and divide by 2. when I hit graph. Let me go back to I need to go back to my negative 10, 10, 1 window. Negative 10, 10, 1, negative 10, 10, 1. You get something like this. This one is kind of two crossed lines. Well, it's hard to see from this exactly what property they want. If I stick on just a straight y equals x, you'll see something fascinating happen. At least it is fascinating to me. The y equals x line is your 45-degree line. And it turns out that any function graphed with its inverse is going to be symmetric about that. That's a consequence of switching the x and y. So the graph of any f with its inverse, with f inverse, is symmetric about the y equals x line. I don't know if you want to see square root and x squared graphed on the calculator, but you'll get the same thing. You have to kind of play with the window to really see it, I discovered when I did this at 12. But an x squared, I got the same right half of it, a square root, basically a horizontal, sideways parabola like that. They will intersect on the y equals x line. Do you want to see it done, or do you believe?
I believe.
You believe. All right. Well, that's pretty much everything that's in this section. So for the rest of the time, I basically did some homework examples. Would you like to see homework examples?
Yeah, I can see a couple.
Okay. So very first one, number 7 off page 262. I'll point it out. It's basically right here. You just give you a graph, you determine if you're one-to-one. And again, one-to-one means it passes a horizontal line test. And most of the places here, yeah, you can run a horizontal line through once and only intersect once in it. But right through the middle, do you see? I drew it here. It's going to fail. You're intersecting more than once right through the middle. So that fails your horizontal line test. This is not one-to-one. If they gave me a formula for this, this would not have an inverse. So no, this one fails. Do you want to see another graph? They give you graphs 7, 9, and 11. Do you need to see another graph, or do you think you're ready? On 13 to 23, they just give you the functions in formula form, and so you must graph and see if it passes your horizontal line test. Are you ready for one of those?
Yeah, sure.
Okay. So I did problem 17, x squared minus 2x. It's right here. Stuff. X squared minus 2x. Same window. Graph it. All right. Can you see, is that going to pass or fail?
Fail.
Horizontal line test.
It'll fail.
Yeah, it's going to fail. So I drew a quick graph here. Here's the y-axis and x-axis. And yes, it fails your horizontal line test. It's not one-to-one. You would have to cut it in the middle and restrict the domain to one half of it. Get it to pass. That goes down from 7 through, let's see, 13 to 23. Do you want to see any others?
No, I understand.
You got those, okay. So then we pretty much skip over the real heart and guts of this. Is from 49 to 69. Well, actually 37, okay. I did give 37 and 39. I just picked out two of them. They give you two functions, and they are, I can show them to you here. Inverse function property, they give you two functions, an f and a g, and they want you to show that they are inverses. And that means you got to plug, say, g into f and show it all unravels and gives you x, and f into g. You want to see one of those done?
Yes, please.
Okay. So I did 37. Show that f and g are inverses. So you could almost guess that they are. You see, I got a -6, you got a +6. Those seem to be inverse to each other, but just to show it, I did f of g of x first. F of g of x plugs in the x plus 6 for the g of x. And I'm getting a low battery. I better go ahead and somehow hope it'll keep going. Let me just double check my computer real quick. I hope it'll keep going. Let me plug in my phone real quick. Okay, maybe that'll keep me going. Apologize for the interruption. So yeah, I plug in x plus 6 for the g, and then when I plug that into the f, you get, for that x, you get x plus 6 minus 6, and sure enough, just x. And so then in the reverse order, g of f of x, that plugs in x minus 6 where the f is. And so then plugging x minus 6 into there, and the x for g, I get x minus 6 plus 6, and again, just x. And that shows the f and g, sure enough, are inverses. You want to see another one of those?
No, I understand.
Okay. So then, yeah, the heart and guts of this is 49 to 69. And that is, here's the formula for the function, find the inverse, which means you got to follow your 3 steps. Anyone in particular you'd like to see, or would you?
Can you do one with a square root?
One with a square root?
Yes, sir.
That would be like 67.
Yes.
Okay, that's the only one I see with a square root. 67?
Yes, sir.
All right. Let me jump to the end. Page 263, f of x, square root of 5 plus 8x, find f inverse of x. I'm just going to follow the 3 steps. Step 1, y equals square root of 5 plus 8x. Step 2, switch x and y. X equals square root of 5 plus 8y. Step 3, solve for y. All right, so to get the y out, I'll need to get rid of the square root. Square both sides. X squared will equal square root of 5 plus 8y squared. So x squared will equal 5 plus 8y. Because that square root and square root undo each other. And you see I'm going to minus 5. Are we going too fast?
No.
So x squared minus 5 is then equal to 8y. Last move, divide by 8. Divide by 8. X squared minus 5 divided by 8 equals y. That is my f inverse of L. I'll just go ahead and use the formula. F inverse of x is x squared minus 5 divided by 8. Questions about that?
No, sir.
Okay. Notice how every operation kind of has this kind of inverse parallel to it. You got a square root in the original, so inverse has a square. You're adding in the original, so you're subtracting here, and you're multiplying by 8, and so dividing by 8 here.
Right.
Want to see another one?
No, I think I understand it all.
Okay. Well, very good. Hopefully this section will go well for you then. I did one last page. I showed the 12 o'clock. Yeah. I made a mistake on the original assignment. I left off 2-3 as being not on the test. So I've corrected that, and the assignment posted in D2L is now correct. It has section 3.2.3 in it. So the test 2 has these sections. It will be proctored. All right, that means it will be inside D2L using something called Respondus Monitor. I'm going to be mailing out instructions this week for y'all to do that. This is the only test that'll be proctored.
Okay.
Have any questions or anything else you'd like to see? Or
No, sir. Thank you so much.
sure thing. We will, I guess, end the meeting.
All right, you have a good night.
Same to you. Have a good night. Thank you for coming out on a late night tonight. Thank you.
for helping me.
Okay.